discussed about the decimation in time FFT algorithm. Already done a problem in the last lecture, that is 3 hours. So next type of FFT algorithm is DIT FFT algorithm, DIF FFT algorithm. That is the second type of fast Fourier transform. In this type, just we observed one problem in the JNTU University is given like this question only. For example, compute the 8-point DFT of a sequence x of n is equal to flower bracket all ones up to 8 by using DIF FFT algorithm. So already we done a problem by using DIT FFT algorithm, that is over, and in the last audio I discussed about the DIFFT algorithm also. Some steps are there in that. Okay, that is over. Next, for this problem we are using DIF FFT algorithm. So before this problem, what we know the twiddle factor phenomena. The twiddle factor phenomena are omega 8 to the power of 0, one twiddle factor, and omega 8 to the power of 1 is the another twiddle factor, and omega 8 to the power of 2, and similarly omega 8 to the power of 3. What is twiddle factor here? In the sense, the twiddle factor is came from this equation, and this is the direct evaluation of the DFT of a sequence is, that means discrete Fourier transform of x of n, that is input sequence. The discrete Fourier transform of input sequence is equal to capital X of k, and that should be is equal to summation n is equal 0 to n minus 1 x of n into e to the power of minus j 2 pi k n by capital N, where small n is equal to 0 to n minus 1, and this is in the form of summation. Another k is a parameter. So here k equal to 0, 1, 2 and so on n minus 1. In this, so I put a small circle in this, that is considered as a omega n. Here omega n is equal to, what is the value? E to the power of minus j 2 pi by n, and this is considered as a twiddle factor. This twiddle factor is very, very important in fast Fourier transform. Okay, for reducing the time and for reducing the evaluation of the number of steps. To reduce that time to that number of expressions, we are using twiddle factor only. Okay, this factor is very, very important in FFT. Okay, and after that this omega n is substituted above equation, we are getting like this. Okay, omega n, that means twiddle factor. Twiddle factor have two basic properties. Okay, and first property is the symmetry property, and second one is the periodicity property. Let's go for symmetry property. When omega n to the power of k plus n by 2 is equal to minus omega n to the power of k, and this is the symmetry property of twiddle factor. And go for periodicity. Periodicity property of twiddle factor is omega n to the power of k plus n is equal to omega n to the power of k. So finally we are getting omega n to the power of k only. So finally we are getting omega n to the power of k only. So that's why we are taking omega n to the power of k in the form of twiddle factor is to taken as omega n to the power of k. For that reason, omega n, here capital N is 8. Why here taking 8? In the sense, the length of the given sequence is 8. You take a 0, 1, 2, 3, 4, 5, 6, 7. 0 to 7 means 8, or 1, 2, 3, 4, 5, 6, 7, 8. Whatever it may be, you taken. Yes, 0 to 7 means 8. So that is the length of the sequence is known as capital N. So that's why we are taking omega n to the power of k. Here already, how it is came 0, 1, 2 and 3. This lecture is already discussed in the last lecture, that is on board. We have taken a 3 periods also. So again I am not saying why, because it take a more time. So